Now this is the next problem. Do it fast. Calculate current in 10 ohm resistance. Where is the 10 ohm resistance? Here is the 10. This is A point and this is B point. First remove the load resistance and redraw the network. I will not discuss that much, just I will increase the speed of the calculations. Remove the load resistance, short the output terminals and redraw the same circuit. Removing RL and shorting output terminals, we get. Draw the figure and do the calculation. Do it fast. Little fast. This is too old. It is 3 ohm. This is 4 ohm. This is 2 ohm again. Here it is 5 ohm and this is 15 volt. Short the output terminal. Here is we are shorting the output terminals. This is A point. This is B point. And we are interested in the calculation of the current. I will use the direct inspection method again. This is I1. This is IN and this is the I2. We have the three currents I1, IN and I2 and we are interested in the calculation of current in the short circuit, which is nothing but the IN. Use any method. But I will recommend here the direct inspection method will be the simple for this particular calculation. Don't use the nodal analysis method here because A and B, we have this branch. And this is complete short circuit and we are not able to calculate its current by using the nodal analysis method. That's why I will recommend use mesh analysis or use the direct inspection method. Here I am using the direct inspection method. I will write the same here. By direct inspection method, we get. Use any method to calculate its current. If you are not comfortable with the direct inspection method, you can use mesh analysis. Is it right? Here will be the matrix. How is this matrix? This is the impedance matrix into this current matrix is equal to the constant matrix. How is the current matrix? First current is I1, second current is IN, third current is the I2. Is it right? How is the syntax or format of this matrix, impedance matrix? How is the format? It is something like this. R11, R12, R13, R21, R22, R23, R31, R32, R33. First we will find out R11. Resistance of the first loop 5 plus 2, that is 7. Second, R22, resistance of the second loop 4 plus 2, that is 6. R33, resistance of the third loop 4 plus 3, that is 7. Yes. We will find out this value common for 1 and 2 loop, 1 and 2 loop 2, that is minus 2 is here, minus 2 is here. Resistance which is common for the first and third loop, first loop, third loop, there is no common element, 0. Then resistance which is common for the second and third loop, second and third loop, this is 4, means it is minus 4, this is minus 4. Is it right? How much is the constant? For first loop, if we are traveling in the clockwise, constant will be plus 15. For second loop, it is 0. For third loop, if we are moving with the direction of the current, that is positive to negative, it is minus 2 is the third constant. Solve this equation and find out its value of the Norton's current, which is IN. Second value which IN is. Use this method and calculate its IN. Do it fast. Yes. Anyone? सौरभ,
I1 0.42.
I1 is
3.42.
I1 is 3.42. How much is the IN?
1.14.
1.14. How much is the
I3 is equal to
I2?
1.67.
1.67 amperes. And this is our answer. We are interested in the IN, that is Norton's current. If we know the value of IN, then calculate the RN, and for the calculation of RN, all sources should be replaced by respective internal resistances. For the calculation of RN, load resistance is removed and all sources are replaced by respective internal resistances. Is it right? Then draw its figure for this case. We are removing the load resistance. Then here will be one resistance. This source will be replaced by the short circuit. Here is one resistance. This is as it is. Here is another resistance. And here will be the another resistance. It will be something like this: 3 ohm. This is 4 ohm. It is 2 ohm. And this will be the 5 ohm. It is A point and this is the B point. Now extend these terminals little outside. Then these two will be parallel, these two will be parallel. This is next figure will be something like this. Here is A point and this is B point. Find out the RN. Because these are the two parallel, find out its parallel combination. These two are parallel. Its parallel combination will be here. Yes. What is the first parallel combination? Unmute yourself, anyone. We have the answer.
One point
1.42 is the first parallel combination. What is the second parallel combination?
point 71.
Yes?
1.71.
1.71 ohm is this value. Yes, how much is the RN? (1.42 plus 1.71), its value is 3.13, I guess. 3.13 ohm is the RN, which is Norton's equivalent resistance. सौरभ सही है क्या ये? Rishikesh, Saurabh, correct?
Yes, sir.
Now, if we know the IN and RN, by knowing this IN and RN, we will draw the equivalent network. Or we will draw the Norton's equivalent network. How will be the Norton's equivalent network? It will be something like this. This is the Norton's equivalent network. I reconnect the load resistance which is removed in the first step. In the first step, we have removed the 10 ohm. We'll reconnect it. It is A. This is B. Its resistance is 3.13 ohm, and its current, which is short circuit current, it is found to be 1.41. It is 1.14 amperes. Yes.
Sir, I get different values of I1, IN and I2.
कितना है?
So I1 2.42.
Just wait. We'll do together. हम parallelly करते हैं. Calculation check करते जाना. I'm using the unknowns 3. मेरा screen पे calculator दिख रहा है अभी?
Yes.
The first value is the 7, second is -2, third value is 0, is constant is 15, then A2 is -2, then 6, then -4, then 0. Is it right? Then A3 is 0, then -4, the next value is the 7, and the next value is -2. How much is the first value? 2.4. Yes.
Yes, sir. 2.42.
We have the different values. This value is 2.42. This is 2.42 amperes. Correct. And how much is the second value?
1.
1 ampere. Absolutely fine. This is 1 ampere. And the value is 0.28. This value is 0.28 amperes. This here, in this case, this Norton's current will be 1 amperes. Absolutely fine. No issues. If we know this IN, now IL is equal to, how is the formula? IN into RN 3.13 divided by IN plus, RN plus RL, which is 3.13 plus 10. Calculate its current.
0.23.
0.23. Method is 0.23 amperes is the load current.